Okay, you guys got it set up? So we are going to follow the same 3 rules, the same basic 3 rules that we've been following. There's only one that's slightly different. The rest are going to be exactly the same. So rule number 1, what's rule number 1? Parallel and then through the focal point. So that's going to be identical. So go ahead and draw that one out. Remember, all drawings are based on the center. So that's beam 1. What's beam 2? Through the focal and then what? And then parallel. Yeah, so this is the only tricky one. So if you notice, if you draw it through the focal, obviously it's never going to hit. So you take your ruler, you aim it with the focal, but you send it to the lens. So we're going to send this to the lens like this. Okay, this is aimed with the focal back here. And then we're going to take our beam and we're going to go parallel. So that's beam 2. And then beam 3 is easy also. What's beam 3? Straight through the center. So that one's going to be the same. Take your ruler, line up your object, aim it with the center, and just send it straight on through. Beam 3. Alright, so what are we looking for? An intersection. So we're looking for an intersection. Well, what do you notice? What's going on with beam 1, 2, 3? They are diverging. Yeah, so they're not converging. They're spreading out. They're diverging. So actually, this will not form an image due to these 3 beams right here. So the concept of this, we've talked about before, is imagine that your eye is looking at this, and according to your eyes, you cannot see refracted. You don't know refraction's going on. According to your eyes, light should just travel in straight lines. And so what you're going to do is you're going to project backwards those 3 beams and look for where the image appears to be coming from. So project back all 3 beams and look for an intersection on the opposite side. Okay, so here's beam 1, and I usually use dotted lines, just so you know this is just what my brain sees. Okay, beam 2, the parallel one. Beam 3, the straight one. Okay, and if you did correct, you should have a nice 3-way intersection. That's your image, or that's the tip of your image right there. As always, go ahead and draw on the rest of it. So there's my image. What do you notice about the image? Okay, it's larger. What else? It is upright. Okay, what do you think about this? Is this a real or a virtual image? Virtual. Again, light actually goes on the opposite side. All the light's over here. We only think the image is coming from this point because we see in straight lines. And so we think we see something there. So it's a virtual. Okay, and this actually, if you think of a magnifying glass, this is the purpose of a magnifying glass, right? Is to see things magnified and to see them still upright. And the way you use a magnifying glass is you bring things up close, right? Let me see if this is going to work here. If I bring something up close to it, okay, I can make it look larger, right? I can magnify it so it looks larger. But what happens if I bring it too far away, outside the focal point? What should happen? It should be upside down, right? And so if you're too far away, it's upside down. If you bring it in close enough, you can get it right side up and you can get it magnified. Okay, so that would be this type of lens. Let's go ahead and measure. Let's calculate, see what we should be getting. I'm getting a DI of about 4.5. That sound good? I'm getting an HI of about 3.5. Hopefully you're in that ballpark. This will be my experimental. Let's see what we should be getting if we drew this perfect. Same equation. What are you guys getting for DI? Did you say 9? Okay, alright, look at, we got that negative here. What does a negative DI mean for lenses? Same side. So this is the opposite for lenses and mirrors. How about H? HI, my HO was 2, negative 429 over HO was, or DO was 2.5. What are you getting for HI? 3 point something? 3 point what? 4.3. Okay, positive. Same, so this is not different. Magnification and M's are not different in their meaning in positives and negatives. Only the distances are different. And lastly, M equals HI over HO. So plus 343. Our original HO was 2. So it's at 1.7-ish. And again, plus means upright. Now what does the 1.7 mean? Larger. So anything greater than 1 tells you that it's larger.